For like 3 agonizing years, immunologist Daria Unitmaz just stared at this medical mystery that made absolutely no sense.
Oh, man. I can't even imagine.
Right. I want you to picture the sheer frustration of this. You've, dedicated your entire life to understanding the human immune system.
Right.
And you have this patient presenting with these overlapping, completely contradictory cellular symptoms.
It's the ultimate puzzle.
Exactly. So you're running tests, you're cross-referencing all the literature, just trying to find some kind of pattern in this massive haystack of biological data. And for 36 months, you just keep hitting a brick wall.
Because, I mean, the human brain can only hold so many variables in its working memory at once, right?
Exactly. He was at a complete dead end. And then in this moment of what I can only imagine was just desperate curiosity, he takes this incredibly complex set of parameters.
Yeah.
He feeds them into GPT-5 and just asks it to map the correlations. And it cracks it. A 3-year, completely impenetrable medical mystery solved just like that.
That moment is just, it's so visceral. It really is a profound human victory over the unknown.
It really is.
We spent so much time talking about, benchmarks and processing power and teraflops that we completely forget what this technology is actually for.
Right, the actual application.
Yeah. It's meant to be a lever that we pull to unblock years of intellectual frustration.
Well, welcome to today's deep dive. We are looking at a really fresh stack of intelligence digests, visual production scripts, and editorial memos today.
And it is a great stack today.
It is. And our mission for today's deep dive is to explore how that single human triumph in medicine is basically acting as the blueprint for the very near future.
Which is happening fast.
Super fast. We're going to look at how custom silicon smart glasses and brand new consent registries are forming the exact infrastructure needed to make those miraculous aha moments an everyday reality for you.
The contrast here is what makes this moment in time so fascinating to me.
How's
Well, if we look at the macro environment right now, the sentiment dials are pretty much locked on extreme fear.
Oh, completely. I mean, the S&P 500, crypto, oil, they're all just taking a beating right now.
Yeah, it's rough out there.
There is this palpable anxiety everywhere you look. But then you pivot to the tech space, and the people actually building these systems are operating with this fierce, informed optimism.
Because the underlying premise of Daria Unitmaz's breakthrough is so incredibly optimistic.
Right. It proves something fundamental.
Exactly. It proves that AI, when applied correctly, isn't some autonomous force acting upon us. It's a tool. It amplifies human expertise.
The doctor didn't get replaced.
Right. His specific domain knowledge was just given a massive computational boost.
Okay, let's unpack this, because I'm looking at the enterprise data in our sources today, and I have a serious pushback.
Lay it on me.
If a single doctor can use this tech on his laptop to solve a 3-year mystery today, why is the enterprise world stalling out?
Ah, yes. The stall.
Right. My feed is full of companies stuck in pilot programs, or they're just completely panicking over security. Why is it so hard to just roll this out so everyone at work can have their own breakthrough?
What's fascinating here is that friction point is the defining challenge of the industry right now.
It really is.
A new TDWI analysis by Koda Signal really diagnoses why this is happening. He calls it the pilot-to-production gap.
The pilot-to-production gap. Okay, break that down for me.
Well, what works for one brilliant doctor in an isolated environment behaves completely differently when you expose it to a massive enterprise.
Meaning what exactly? Like, is the software just breaking when too many people use it?
It's more about the unpredictability of the data and, honestly, the users.
Oh, sure.
In a pilot program, you have a handful of, enthusiastic early adopters playing in this carefully curated sandbox.
Right. Clean data.
Exactly. But in production, you have thousands of employees throwing incredibly messy, poorly formatted, completely unpredictable data at the system.
So how do you fix that?
Signal prescribes a very specific mechanical fix for this stall. First, companies need representative evaluation sets.
So instead of testing the AI on perfect, clean data, you test it on the chaotic stuff real employees actually generate.
Yes, you simulate the chaos.
That makes sense.
Second, he points to cost dashboards. Because, the compute bill for 1,000 employees running complex queries.
Oh, I bet it skyrockets.
It can bankrupt a department overnight if it's not tracked in real time.
Yikes. Okay, so evil sets and cost tracking.
And third, and arguably most important, you need a kill switch.
I was going to ask about that. How does an AI kill switch actually work? Because we aren't talking about, like, unplugging a server rack in a basement anymore.
No. A modern kill switch operates at the API level.
Okay.
Let's say an AI agent starts hallucinating, or maybe it starts pulling sensitive HR data it definitely shouldn't access.
A nightmare scenario.
Right. The kill switch instantly severs the agent's permission tokens.
Oh, I see.
It doesn't delete the AI, but it instantly cuts off its ability to reread, write, or interact with the company's internal systems.
Which brings us to the security panic. Because it isn't just about the models getting confused by messy data.
Not at all.
CrowdStrike just issued a major warning about this, flagging that AI agents have a hidden identity problem.
Yes, this is a huge deal.
I read the memo, but the concept of software having an identity problem feels, I don't know, a bit abstract.
Let's ground it in how enterprise security actually functions.
Okay.
The entire system is built on identity verification. I need to know that you are you before I let you read this confidential file.
Right, my login, my password.
Exactly. Now, imagine you deploy an autonomous AI agent to help manage your workflow.
Sure.
For that agent to be useful, it needs your credentials. It needs permission to read your emails, draft responses, query the financial database, maybe even send messages on Slack.
So it's essentially wearing a digital mask of my face while it runs around the company servers.
That is a perfect way to put it. Now, what happens if that agent gets compromised?
Oh, man.
A malicious actor doesn't just get access to a chat window.
Yeah.
They inherit your entire digital identity within the company.
The blast radius expands exponentially.
Exponentially. If an agent with your permissions gets hijacked, the system can't easily tell the difference between you doing your job and the hijacked agent exfiltrating data.
That is genuinely terrifying.
It really is.
So the enterprise world is pausing because they have to figure out verifiable identity controls for software that acts like a human employee.
Exactly. They are building the invisible guardrails. But even if we solve the software governance, we hit a much harder physical bottleneck.
The hardware.
Yes. The raw physical cost and energy required to run the math for millions of people to have these breakthroughs, it's simply unsustainable on our current hardware.
Right.
The engines themselves have to change.
I am so glad you brought this up. Now, typically, when a new computer chip drops, the conversation devolves into this exhausting hardware benchmark horse race, you know?
Oh, entirely. It's always about the specs.
Right. Everyone argues over who has more teraflops, whose stock price is up, who's winning the data center war.
Yeah, we're not doing that.
Exactly. We are skipping all of that today to focus on the actual mechanics and tangibility of what OpenAI and Broadcom just unveiled.
It is a massive shift away from the spec sheet and toward the architecture's actual purpose.
I was looking at the visual description of this custom LLM inference chip in our production notes, and it's stunning.
It really is beautiful in a geeky way.
It's described as a brushed obsidian black dye with an iridescent sheen. And the phrase they used in the source was silicon built for thought.
Silicon built for thought. That captures the architectural pivot beautifully.
Yeah, what does that actually mean under the hood?
Well, up until now, the entire AI boom has been running on general-purpose graphics processing units, or GPUs.
Right, the standard chips.
Now, the audience knows GPUs are incredibly powerful, but we have to remember their original architecture.
Gaming, right.
Exactly. They were designed to move massive parallel blocks of data to render complex graphics in video games. They were not explicitly designed to calculate the probabilities of human language tokens sequentially.
Here's where it gets really interesting, because I was struggling to visualize why this matters, and it finally clicked for me.
Let's hear it.
It's like we've been using high-end luxury sports cars to plow massive farm fields.
Oh, that's a great visual.
Right. A sports car has a ton of horsepower, and if you strap a heavy plow to it, yes, it will eventually turn the dirt.
But it's going to struggle.
Wildly inefficient. It burns through fuel, the engine overheats, and it's just fundamentally not what the machine was built to do. And now OpenAI and Broadcom have finally just built a tractor.
A tractor?
A machine specifically designed for the harvest.
That analogy hits the absolute core of the issue. They have built an inference chip.
So break down inference for us.
To clarify the mechanism here, training an AI model is like having it read the entire library to learn the language. That requires massive parallel processing, the sports car, so to speak. But inference is the phase where the AI actually answers your specific question. It's the real-time writing of the essay.
And writing the essay requires a totally different flow of memory and computation.
Exactly. When you design purpose-built silicon for inference, you optimize for how language models actually move memory.
So it's way more efficient.
Every single watt of electricity does more work. You stop wasting power on graphical processing architectures that the text model just doesn't need.
Wow.
You are making the math of discovery fundamentally cheaper.
So we're shifting from begging for time on borrowed, repurposed hardware to designing custom environments where language models can actually breathe.
Yes. And think about the implications of that. Consider what happens when that computational cost plummets.
Everything speeds up.
When the hardware becomes this efficient, the friction of curiosity just disappears. You stop worrying about how much a complex query costs to run in a massive data center, and you start wondering, what impossible problem should I throw at this next?
It completely democratizes that moment Dr. Winnetma's had.
Exactly.
If the math is cheap, anyone can afford to ask a 3-year-long question.
Anyone.
But there is a secondary effect to this hardware becoming so efficient, and I think it's even more disruptive.
Oh.
When inference gets this lightweight, AI stops being a heavy program you have to visit on a desktop,
Right.
It becomes something you can literally wear.
Ah, yes. The physical footprint of the intelligence shrinks to the point of ambient integration.
And Meta is proving it right now. They just launched the new Meta glasses, built in partnership with EssilorLuxottica.
This is a huge leap.
Let's look at the tangibility again, because this is crucial. This is not a bulky, dystopian sci-fi helmet that traps you in a virtual reality box.
No one wants to wear that to the grocery store.
Right. It's 26 different styles of normal-looking glasses. They are compatible with your prescription lenses. It's basically an evolution of the Ray-Ban line.
It's the realization of ambient computing. The hardware has finally caught up to the human desire to get answers without having to look down at a screen and disrupt our connection to the physical world.
It seemed like
the world around you becomes annotated.
the world annotated. I absolutely love that framing.
It changes everything.
You are looking at, say, a broken pipe under your sink or a really complex spreadsheet on your desk, and the intelligence is just right there in your field of vision, walking you through the solution in real time.
It seamlessly weaves into daily life.
And what blew my mind in the sources today is that this ambient integration isn't just visual, it is completely transforming audio too.
Oh, absolutely. The AI leaving the screen applies heavily to how we interact with sound and narrative.
I couldn't believe the 11 Labs release when I read about it.
The audiobook.
Yes, they just dropped a 13-hour audiobook of Homer's Odyssey, but it is narrated by an AI voice clone of Michael Caine,
Which is wild.
alongside 20 other AI-generated voices, complete with AI-generated music and cinematic sound effects.
It is a staggering demonstration of synthetic media generation.
But what I really appreciate is how their marketing lead, Jack McDermott, framed it in the sources.
How do you put it?
He didn't position this as an attempt to replace human voice actors or wipe out the studio industry.
Which is the usual fear.
Right. He framed it as combining human creativity with AI tools to revive an ancient story.
I like that.
A single creator can now sit at their desk and produce a 13-hour epic that would normally require a massive studio budget, a casting director, months of complex scheduling.
That is an incredible creative unlock. But
Yeah.
this raises an important question.
Go for it.
If the technology is now capable of reading our daily physical environments through the cameras on our glasses, and it can flawlessly clone the iconic voice of Michael Caine for a 13-hour audiobook,
Right.
how do we maintain ownership of our own identities?
I was thinking the exact same thing. I mean, I love the idea of Michael Caine reading me a story, but I don't exactly want an AI cloning my voice to read my boring tax emails to someone else.
Or worse, using your voice and likeness to bypass those enterprise identity controls we discussed earlier.
Oh, wow. Yeah, the security angle.
Exactly.
Yeah.
How do we protect ourselves without stifling this amazing creative and scientific progress?
That is the tightrope. Because the rapid deployment of these intimate technologies, glasses that see what you see, software that speaks with your voice, it demands an entirely new kind of social infrastructure.
It really does. The old rulebooks just do not apply to this reality.
We need forward-looking solutions, which brings us to the Human Consent Registry.
Right. Cate Blanchett's project.
Yes, this is a new tool co-founded by the actor Cate Blanchett. And I want to pause here because it is so easy to frame stories about Hollywood actors and AI as these doom and gloom, fear-mongering narratives about the end of art.
The whole machines are taking over angle.
Exactly. But the sources show this is actually a proactive structural solution.
The Human Consent Registry is designed to be a machine-readable record of AI permissions for a person's likeness and their voice.
Wait, let me push back on this because our sources note that compliance is completely voluntary right now.
It is, yeah.
So, if there's no enforcement mechanism, how does a voluntary registry actually stop a bad actor from just ripping my voice off the internet anyway? It sounds like a suggestion box for pirates.
That is a fair critique of its current state, but you have to look at how infrastructure is actually born.
Okay, tell me.
Before you can enforce a law, you need a verifiable standard.
Right.
The registry provides machine-readable metadata. It establishes a cryptographic record that clearly says this person did not consent.
Ah, so it's a baseline.
Exactly. Even if bad actors ignore it today, it allows the major platforms, the hosting sites, the app stores, the enterprise networks, to build automated checks in the future. They're laying the standardized tracks before the regulatory train gets up to full speed.
Okay, so it's about giving individuals agency over their digital selves in an annotated world and giving platforms a way to actually verify that agency. And we are seeing these new structures popping up everywhere to help organize human behavior and handle all this rapid change. For instance, Meta reportedly has internal plans to launch an AI-powered prediction market app.
To compete with platforms like Kalshi and Polymarket, yes.
Right. And fundamentally, a prediction market is just a way of organizing human hunches.
Exactly.
You use the AI to help weigh probabilities and allow people to bet on the future. It's a new way to aggregate what the crowd thinks is going to happen next, building a new structure to navigate uncertainty.
And we need all the help we can get with uncertainty right now.
Definitely. But what is truly wild is that it isn't just tech companies scrambling to rewrite the rules. We are seeing legacy physical systems adjusting their own frameworks to match changing realities on the ground.
The tension we are seeing in the digital space, this desperate need for new rules, is absolutely mirroring a restructuring happening in our legal systems.
Exactly. And just to be absolutely clear to you listening, we take no political sides on this deep dive. Regardless of where anyone stands politically on this issue, from a purely systemic view, the U.S. Supreme Court just issued a ruling that significantly relaxes deportation rules for green card holders.
Yes, it is a decision that reshapes immigration enforcement protocols immediately.
Just structurally shifting how things work.
Mechanically speaking, it eases restrictions on long-term residents and entirely alters how the legal system processes these specific cases moving forward.
So what does this all mean? We have Hollywood actors building machine-readable consent registries to protect digital voices.
Yep.
We have tech giants building prediction markets to map future uncertainties. We have the Supreme Court rapidly rewriting the rules of physical enforcement. We have all these seemingly disparate threads.
If we connect this to the bigger picture, it tells a very cohesive story about human resilience and adaptation.
How so?
Well, we started this conversation by noting that the financial markets are currently gripped by extreme fear. People are really anxious about the macro environment.
They really are.
But look at what the builders are doing. From Cate Blanchett to the engineers at OpenAI designing new chip architectures, to the justices on the Supreme Court adjusting legal frameworks, they are not paralyzed.
They're moving.
They are actively drawing new lines. They are building new structures, new hardware, and new rules to manage and thrive in a world that is fundamentally different than it was 3 years ago.
They are acting with that informed optimism we talked about earlier.
Exactly.
Which brings us full circle, because all of this, the custom inference chips, the new smart glasses, the consent registries, the enterprise kill switches, all this infrastructure is being built to support the human win.
The goal is to widen the front of what is humanly possible.
We started today with Dr. Daria Unutmaz cracking a 3-year medical mystery.
Such a great story.
It is. And he didn't achieve that because he suddenly became a master computer scientist, you know?
No, of course not.
He achieved it because the tool finally became accessible enough and the underlying systems powerful enough to amplify his specific human expertise.
He had the domain knowledge, and the AI provided the computational leverage.
And as custom silicon makes the math cheaper, and as smart glasses move the interface off the screen and into our physical environment, that capability is going to scale.
It's going to be everywhere.
It is going to reach you. The infrastructure is being laid down right now so that you can have those exact same moments of profound discovery without needing a massive research grant or a supercomputer.
AI is becoming the tractor that helps you harvest your own field.
I love that. So, as we wrap up today's deep dive, I want to leave you with this to ponder. If the falling cost of intelligence means an immunologist can crack a medical mystery today, what impossible years-long problem in your own life or work might just be waiting for the right prompt?